In p-type semiconductors, a small amount of impurity from group 3 of the periodic table, such as boron, gallium, indium, or aluminum, is added to the pure semiconductor. These atoms contain 3 valence electrons in their outermost shell. When these impurities are added to the pure semiconductor, 3 valence electrons form covalent bonds by sharing 1 electron with the electrons of the neighboring atoms. The 4th covalent bond is left incomplete, which creates a hole. Such impurities create a hole which can accept electrons, so they are called acceptor or p-type impurities. Look at the energy level diagram. You can see that the acceptor energy level, which belongs to the holes of acceptor impurities, is really close to the valence band. So by receiving a very small amount of energy, for example the room temperature, some electrons from the valence band leave the band and occupy the acceptor energy level. Therefore, holes are created in the valence band, which are the empty spaces of these electrons. Also, by receiving more energy, just like a pure semiconductor, some covalent bonds will break and electrons move from the valence band to conduction band. This produces holes in the valence band and free electrons in the conduction band. It is clear that because of the added impurities, we have more holes in the valence band than a pure semiconductor. So the number of free electrons in the conduction band decreases below a level that would be available in a pure semiconductor, because the large number of holes in the semiconductor increases the rate of recombination with electrons. Compared to an intrinsic semiconductor, in an extrinsic p-type semiconductor, we have a greater number of holes in the valence band and a fewer number of electrons in the conduction band. If you take a look at the p-type semiconductor on the right-hand side of the screen, you will notice that due to the external electric field, electrons are attracted to the positive plate and holes are gathered near the negative plate. But the number of holes are greater than the number of electrons. This is due to the acceptor impurities. Therefore, in a p-type semiconductor, the current flows due to the movement of electrons and holes. But a major part of the current is due to the movement of holes. The holes in a p-type semiconductor are known as majority carriers and electrons are known as minority carriers.